Hello, this is Mr. West working on that canvas, and today we're going to start with the first lesson, 9.01, Events and Outcomes in a Sample Space. This is for Algebra 2. Here we go. So, how these videos are going to work, I'm just going to go through the lesson and kind of go through each examples. I might skip a few things, but here, they're trying to define a sample space. And they use the example of flipping a coin. So when you flip a coin, there's only two possible outcomes, heads or tails. You can argue it lands on its side, but you don't worry about that, just the heads or tails. So outcomes, they call them elements. And, elements are the individual things that can happen. So heads can happen or tails can happen. The sample space is all of those elements together. So it would be the two outcomes. They say heads or tails, or heads, comma, tails with the weird brackets. So they give a more in-depth example. Let's say we have a head. They're tossing 3 coins, and they want to know, what's their question? They want all the different possibilities of the 3 coin tosses, and they lay it out here. But I'm gonna go do it again. So we're flipping 3 coins. So the first coin can either be heads or tails, and this is called, I think, the tree method. And I'll try to write a little bit better. Second coin so the second coin is also heads or tails, and then those branch off into heads and tails for the third coin toss. So when you're listing it all out, I'm going to follow the top branches. Let's see if I got a highlighter for this. If it'll let me. So I'm going to I'm listing them all out. So I got heads, heads, heads. Can't use please. So I have heads, heads, heads. And if I follow that same line and then go here instead, that's heads, heads, tails. And then take the middle row, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So these would be all of my elements. So my sample space, if I toss 3 coins, would be all of that. And let's go back to the lesson, and that's what they listed right here. And they actually broke it up in the description. So all 3 coins landing heads, 2 coins landing on heads, 1 coin landing on heads, and another coins landing on heads. Sometimes you want to break it up like that if the question is asking something specific, like what are the chances of only 2 of the coins being heads? So you only have 3 out of the total. So let's move on to the next lesson, or next part of the lesson. So now they want to use dice. So let's look at the pair. They call them cubes for some reason, but they have 6-sided dice, 2 of them, and they roll them. Let's see, what are they asking for? what is the sample space, and what is the... You're right. Before we go, I'm going to head back to the first page because I just remembered that they didn't talk about this, but they have a question on it. Subsets. So when we have a set, let's say this is our set here. Let's call it set A, and then we have set B. Actually, let's just use a new example. Can I have a new page? So set A, let's just call that 1, 2, 3, 4, 5, and set B is just 4 and 5. We can say that set B is a subset of A because all the elements in B are in A. So because A is a larger set and B is a smaller set, and everything in A is it, or everything in B is in A, set B is a subset of A. So I just wanted to go over that particular example. They didn't go over it very well, or at all. So now we can move on to the next page. Next page. Alright, so they're using dice, and they kind of break it up. But if you roll dice, let me draw a picture for you. Oh. So here's the dice. I roll a 1, then a 1. A 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6. Oops. Get me right, please. Well, you get the idea. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. 3, 1, 3, 2, 3, 3, and let's keep going. So when you roll a pair of dice, these are all the outcomes you can get, as long as the dice are 6-sided. I guess that's why they use the term cube. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So those are all your possible outcomes. Oh, okay, so they want, what is the sample space for the sum of the pairs of the pair of dice? So you could only have, so sum, remember, means addition. So that means you can have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, and 12. So when you add the 2 dice together, these are your only options. And they list it out quite nicely right here. And then they show the whole sample space if you just roll 2 dice. Now they ask, suppose that you will win another roll if you get doubles on the first try. What are the different ways that can this happen? So you can roll double 1s, double 2s, double 3s, double 4s, double 5s, and 6. And then what are the chances that you roll doubles? So, out of, if you count them all up, there are 36 possibilities of what can happen. So out of those possibilities, there's only 6 doubles. So that's 6 out of 36. When you reduce that or simplify it, it becomes 1/6. So those are your chances. And then here, they finally say a subset. It's a group of elements in a sample space. Think of it as a smaller piece to a larger puzzle. Alright, example 1. Using the same dice, think about the event of rolling a sum that is greater than 10. This event would consist of all outcomes where the sum is greater than 10. So, let's just, think. So, let's go back to our list here. So, sums that are greater than 10, so not equal to 10, but greater than 10, so 11 and 12. We only have 3 possibilities, so 3 out of 36, or 1 over 12. Now, if you ever run into a situation where it can't happen, we call it the empty set, and it's just the null set sign there, the circle with the slash through it. That's if we ever have, like for example, if I was drawing a card out of a deck of 52, the ones with ace, 2, 3, 4, 5, 6, all the way to jack, queen, king, what you play with normal card games. If I drew a card and I was asking what's the probability of it being green, and the whole deck is blue. So that would be the null set because the probability of drawing a green card is example 2. Example 2. Oh, wait. Example 1 and example 2 are the same. They're just listing out the 3 possibilities: 5, 5, 6, 5, 6, 6. Remember, not equal to 10. They said greater than 10. Alright, let's go to the 3rd page. 2-way tables. They're categorical or qualitative data. You divide it into different groups, and usually qualitative is like not numerical, like eye color, hair color, favorite school subject. Quantitative is numerical, such as height, weight, temperature. Right now we're going to focus on categories of data. So the principal of your new school in your neighborhood needs a demographic breakdown of a couple of elective classes. So here's the list of information he's collected. 175 male students want to take music. 415 male students want to take music. So on and so forth. And they want to make us fill out this table. So how many males that want to take music? I cannot. Oh, here we go. 175. 415 wants to take music. 285 wants to take drama for females, and 25 males want to take drama. And so what they did here is they added a total. So you just look at the row here, or the column. This is the column. And add them up. 175 plus 25 is 200. And then 175 plus 415 is 590. And that is how you complete your table. So example 1, they want to organize this table here. So the company called 1,000 people. So the number in the corner, which is the totals of how many adults and children, should be 1,000. So 750 people were registered voters. So since children can't be registered voters, there's 750 registered, and then 0 children registered to vote. So there's 750 total in that column. And then we have 100. So they said 895 people were adults. So that goes in the total for the adult row. So to find the amount of unregistered adult voters, we take 895 minus 750. So we get 145 unregistered voters. So that row is complete, and that row is complete, and then we should be able to find the others by looking at this last data here. 105 people were children and not registered to vote. But they voted anyways. Let's not go into that. So there's the 105 there. It means we can find our totals. Another way we organize data is through Venn diagrams. Wait, where's the Venn diagrams? Let's just use their example here. Here we go. So an avid sports fan kept detailed records of the last 180 games. Data she compiled listed below. The team scored first in the 98 of the games. The team won 125 of the games. The team won 82 games in which they also scored the first point. So she divided up into scored first and won. And their intersection here is them scoring first and winning. And then these 39 represents everything outside this circle is they lost. So the team lost. The team lost and they did not score first. So there were 16 games where they scored first but lost. There are 43 games where they won but they didn't score first. So let's redo how did they make this Venn diagram? So let's redo this. 180 games. '98 scored first. Team won 125 games. So they won 82 while scoring first point. So we draw our two circles. First score and then win. So they won 82 games where they scored the first point and won. Okay. That means there was since there was 82 games where they scored okay. So there were 82 games winning while scoring 82 wins while scoring first point. That means there was 18 98 minus 82, 16 games where they scored first but still lost. Okay. And they won 125 games. So out of the 125 games that they did win, they scored first 82 times. So that means there's 125 minus 82 games where they still won but not got the first point, which is 43. I guess I could have done the math. And then lastly, we count up these numbers, 16 plus 82 plus 43. That would be 8, 1, 1, 2, 0, 141 games. That means the rest where they lost and did not score the first point, there's 39. And that goes outside. So that's where they got those numbers from. Alright, let's go to the next page. Unions, intersections, and complements. Making sure. So the universal set is the set that contains all the elements. Intersection is A and B. So let's do an example here. I'm not going to use their example. So my example, here's set A. 1, 3, 5, 7. Set B. 2, 4, 6, 8. So the universal set would be everything. So that would be 1, 2, 3, 4, 5, 6, 7, 8. Union. So if I say A union B, so you know it's a union because it's a U. That means another way to say it is A or B. So it means 1, 2, 3, 4, 5, 6, 7, 8. A intersect B, and I'm going to change the problem a little bit. I'm going to say that set B also has 3. So there's nothing changed by the universal set or the union. 3 just appears, 3 is still there. A intersect B, which means A and B. That means it has to occur in A and B. So there's only one possible case in this scenario, since I just added, as 3 appears in both. So 3 is just there. Now remember, you can always say the null set, so you have a set with nothing, if there is nothing. So that's what A intersect B looks like. And then they have complement. So complement, which is weird in this case, they usually say A prime. Complement basically means not A. So if I say A complement or A apostrophe here, or they call it A prime, it means not A. So everything that is not A. So that would be 2, 4, 6, and 8. Not B or B complement. B complement would mean not B, which means 1, 5, 7. So notice 3 was in both of these, so it cannot be in B. So 1, 5, and 7. So that's how all of those work. So example, you and a friend are going shopping in a new car in the car dealership, and you can choose from electric car, gasoline car, or hybrid vehicle. You want to choose between, and your friend wants to purchase only an electric vehicle. So describe the scenario using sets. Okay. E stands for electric, gasoline, hybrid. So they're making up their own sets. And they're asking, what is C intersect D? So intersection means upside down U. And that means it has to appear in both C and D. So the only one that should be there is electric, which is what they have there. C union D, which means C and D, this should be electric and hybrid. And then D prime is D complement, which means not D. So anything that is not D, which is gasoline and hybrid. Alright, let's move on. You try. So hopefully you can go through these examples that they give you. Make sure to check your work. This first one, basically divided into a ceremony or no ceremony. There's 185 students, so that's where that total comes from. 98 seniors will be attending. 143 seniors will also be attending, or 143 seniors. Yeah, so they got ceremony, no ceremony, party, no party. And then you just fill that out. Light bulb company randomly tests 2 bulbs out of every 100 manufactured. The light bulbs are either good or defective. If both bulbs are defective, then all 100 bulbs are discarded. So they will only discard them if both bulbs are bad. So what are the chances that all 100 bulbs will be discarded? So there's only one event where both bulbs are defective. But there are a total of 4 outcomes in the sample space. Because you could have good or defective, or vice versa, defective or good. And then lastly, bad. I think they wanted to... I think they wanted this last row to be 0 bulbs and then defective. But it means there's a 25% chance that all bulbs will be discarded. Because there's 4 possible outcomes. You can get good, which is 1 possible outcome. Good or defective or good, or defective. So if they all equally have a likely chance of happening, then you have a 25% chance because it's 1 out of 4. No. Alright, back to the last page. Make sure you review the lesson. Give the quiz a try. Remember, you have unlimited attempts. After the second attempt, you have to email me to get more attempts. Hopefully this helps you out. Have a good day.